Hi, this is Mr. Manley. In this video, I am going to look at some inverse applications. Now, hopefully you have some familiarity with inverse. I do have a video on an introduction to what inverse means. And here I'm going to apply those definitions or those understandings of what inverse means. And what I looked at or what I look at when I introduce the inverse is I look at it graphically, numerically, and algebraically. And these are the three ways that I look at a lot of the work that I will do with functions with students. So here is inverse, and as you can see, I'm looking at a graph, so I'm going to be talking about the inverse graphically. So first of all right, before I actually do this problem, I just want to give you the big idea. The big idea is that if I take the line y equals x, and hopefully you know what the line y equals x is, what that looks like. So that's the line y equals x. And that's actually not part of the graph of the function, so I'm going to dash it here, and I've also got it in red. So what we've got here is I've got some function here that is given. I'll just highlight that for a moment. There, so that's the function that's given. The inverse of that function is the mirror image of it through this red line. So do you know what I mean by that? Do you know what it means to be the mirror image? The mathematic term for this would be symmetric with respect to the line y equals x. So let me just kind of freehand draw that. That. Something like that and that. So can you see that? How I've got this side, and then I'm going through this line and reflecting over this side, and I have this nice symmetric figure. So that's what it means to be inverse graphically. It's a reflection through the line y equals f. So in this case, this would be the function f, and this would be the function f of negative 1. F of negative 1 means inverse. So this means the inverse of f. Does not mean an exponent. This does not mean this. Does not mean that, because f is not a variable, and I've said this in other videos. F is the name of a function, so I do not operate upon it like I operate upon a variable. Sometimes it looks like I do, but that's not what is actually happening. F of negative 1 is just a phrase that means inverse. It does not mean 1 over f, because f is not a variable. F is the name of a function, which is a collection of variables. Okay, so let's, now, this is not good enough at this point, this f of negative 1 graph. So this, I don't know, it's pretty close, but I just did it freehand. So I need to be more specific. So let's look at how I can get more specific here. Okay, so I'm going to take this off. And let's see how I can be more specific. If I've got this point here, and I've got this line, then I am going to go and reflect that point right there to the other side of the line. Now another way of doing this is if this is point, what is that point? 6, 7, it is 0.8, 7. So it has an x coordinate of 8, y coordinate of 7. This point here, the reflection is going to reverse these points. I don't know if reverse is the word I want to use. It's going to invert them because this is inverse. So I'm going to have 0.78. Okay? A thing about the inverse and its a function and its inverse is that they share, if the function crosses the line y equals x, then the inverse will cross at the same place. So I also have this point here, I know. So I don't know if you can see that I did that, but just to clarify, right there, let me use even a different color. Right there, I put a point for the inverse, because if the function has a point on the line y equals x, then its inverse has that point too. So I've got that point. Now I need to, now this line's going to come down here, reflected, see? So this is getting reflected over here. But to be more specific, I want to go to this reflection point here. So this 6 is here. So it's going to be 6 over here. See that reflection? This is reflecting over here. So if I take that point and then connect those dots, there. And then this point here is at -3, -3, 4. So if you've been following along, what other point do I know I have? I know I'm going to have 4, -3. So I'll put that point, and let's connect to that, and that's it. So the key is really taking these corners here, that corner, the end points and the corner points, that point, and you can take those points and then invert the x and y and get the other point, or in some cases you can see the reflection, like from 6 to 6. That's a pretty clear reflection there. Okay, so that's inverse graphically. All right, here's inverse numerically. So we don't have a graph. I've got a function g here, and then I'm asked about its inverse. Now in this problem, what I'm gonna do here, you really will find that you end up not needing to do this every time. But for the sake of instruction and to really understand this, I'm going to do it. If this is g, then g of -1, its inverse, is the inversion of all of these points. So I'm going to switch the x and the y. Now you're not going to have to do this, all of these every single time, but I'm going to do it here, just to be clear on what we're dealing with. 4284 and 06. Okay, so if these are the points of the function g, the points of its inverse are all inverted. Switch x and y. All right, now let's go down to what is being asked about g, or about g of -1. So here's the way that I would read this. I would say g -1 of 4. G -1 of 4 is how I would read that. And then what it means is it's a function. It's the inverse function g -1. And I want to know what is 4 when x is 4. Of course, from all of our work with functions, we know that this means, when I have the parentheses there, that means x is 4. So when x is 4, what's the output for the inverse function g? So I just go over here and I find x is 4. So when x is 4, what's the output? 2. So g -1 of 4 is equal to 2. Okay? And that's numeric. That's what we do numerically with a function and its inverse. We have the numbers for the function, and then we switch the x and y, and we get the inverse. And here we can evaluate an input into that inverse function and what the output is. All right, so that was numeric, and we looked at graphically. Now, this question here, what is h negative 1 of x? What is h negative 1 of x? Is going to prompt me to work algebraically. So again, I worked graphically with inverse. I worked numerically with inverse. Now I'm going to work graphically with inverse. So how do I find h negative 1 of x? Well, here is h of x, and what I'm going to do is it's a step-by-step process. Like step 1, I'm going to substitute y for the name of the function. So the name of the function here is h of x. Could be f of x, could be g of x. Whatever the name of the function is, I'm going to substitute a y. That's step 1. Step 2 is I'm going to switch the x and the y. So do you see what I did there? Switched the x and the y. And that makes sense, inverse, to be doing this for inverse, right? Because we just did that numerically. We inverted. So we switched the x and the y numerically, and that's what we're doing here, algebraically. We're switching x and y. And then the final step is to solve for y. So I'm going to kind of do this now you need to be able to solve for y in an expression or an equation like this. I'm going to do it in one fell swoop here and just go, all right, this is 5x minus 2. So you need to be able to get to that correctly. And then once I have y isolated, now I've got the inverse. So the inverse is equal to this. And then I just would name it correctly, or I would state it correctly that, all right, so therefore, since y is equal to 5x minus 2 after I switch x and y, that means that h negative 1, the inverse of h, is equal to 5x minus 2. And that's my answer to this question here. So I'll put it over to the left since I don't really have room. So, all right, so that's what the inverse of h is. All right, I'm going to tell you something here, and I could go into some instruction about this, but might take a little bit more time than I'd like to add on to this video. So I'm just going to tell you. So here, hopefully you recognize this as a function composition. And you could go through and so you should be able to, if you understand function composition, you should be able to rewrite this as h negative 1 of h of 3, and then you would ignore the h negative 1, and you could find h of 3. And then once you find that result, you could do h negative 1 of that result. So this is function composition, and you should have seen this before if you're up to this point in a pre-calculus class. Well, I'm going to tell you, this problem here, when I do the composition of a function and its inverse, whatever value is here, that's what it's going to evaluate to. So you could try it. You could do the composition and see that's what's going to happen. But I'm telling you, it's not exactly a trick, but this is what is going to happen. So if I do h negative 1 composition h of 1, that's equal to 1. If I do negative 5, it's going to be equal to negative 5. The composition is going to be equal to negative 5. If I do a, some non-numeric value, I'm going to come out with a. If I do x, it's going to come out to x. This is what happens with a composition of a function and its inverse, and that will happen every time in this problem.